All right, let's jump right into this explainer. Today, we're demystifying the universe's ultimate invisible superhero force, gravity. You know, whether you're sitting in your classroom right now, hanging out in the kitchen, or just looking up at the night sky, gravity is the hidden boss pulling the strings. We're going to find out exactly how it shapes our world, how it actually builds entire galaxies, and what would happen to us if it just suddenly turned off. Let's get into it.
So, to kick things off, I've got a fun puzzle for you. It might look like magic, but it's actually an awesome science trick you can do right at home. Now, if I told you that you could take a glass totally full of water, flip it completely upside down, and not spill a single drop, you'd probably think I'm crazy, right? Because, well, gravity's supposed to pull that water straight down. But what if we could use another invisible force to fight gravity and actually win? Here's how you can amaze your friends. Grab an adult to help out and follow these steps. Watch as the water totally defies the rules. First, fill a glass up to the very brim with water. Then, place a stiff piece of paper or cardboard right over the mouth of the glass. You want to make sure there are no air bubbles in there. Next, hold the glass in one hand, press the paper flat with the other, and quickly turn the whole thing upside down over a sink. Finally, move your hand away from the paper. It literally stays. But how is that even possible?
Well, the secret here is air pressure. Because there's no air inside that glass, the invisible air pressure in the room pushing up underneath the paper is actually greater than the weight of the water pushing down. It's like this epic invisible wrestling match. Gravity is pulling down hard on the water for sure, but the air pressure is pushing up even harder. So in this one specific trick, air pressure takes the win over gravity.
Moving on to Section 1, Gravity in Daily Life.
Now that we've managed to beat it in the kitchen, let's talk about how gravity acts as our invisible helper everywhere else. I mean, it's practically running the entire planet. It gives physical objects their weight, which is really just a measurement of how hard the Earth is pulling on them. And did you know it even helps plants survive? Gravity actually tells plant roots which way is down so they know where to grow. It's a super cool biological process called gravitropism. Plus, the gravity from our moon reaches all the way across space to physically pull on Earth's oceans, creating the tides you see at the beach. It even helps drive our weather patterns. Honestly, gravity shapes our everyday world in ways we barely even notice.
Next up, Section 2, the invisible space-time trampoline.
So, let's zoom out into space for a second and figure out what this invisible superhero actually is. Back in 1915, Albert Einstein had this brilliant realization. He figured out that gravity isn't just a simple pull or like some giant magnetic rope. It's actually a curving of the universe itself. He called this fabric space-time. So think of empty space not just as an empty room, but as a giant flexible sheet. And anything that has mass, meaning anything made of stuff, makes a little dent in that sheet. A great way to picture this is to imagine a heavy bowling ball sitting right in the middle of a giant trampoline. That heavy ball represents a massive planet like Earth, and it makes the trampoline mat dip way down in the center. Now, if you were to toss some smaller marbles around the edges of that trampoline, what happens? They naturally roll down the curve right toward the heavy bowling ball. And that is exactly what's happening with us. Massive objects like the Earth bend space, causing us, the little marbles, to constantly just roll toward the ground. That's what gravity really is.
Which brings us to Section 3, Building Stars and Galaxies.
You know, this amazing bending of space is actually responsible for building the entire cosmos we see in the night sky. Without gravity, the universe would honestly just be a really boring, dark, dusty cloud of nothing. Let's jump back to the early universe to see how this works. Billions of years ago, space was filled with these huge, floating clouds of primordial hydrogen gas and clumps of mysterious dark matter. Slowly but surely, gravity started doing its job, pulling all those clouds together into tighter and tighter balls. As that gas got squished closer together, it got hotter and much denser. Finally, gravity squeezed the center so incredibly hard that the gas ignited in a process called nuclear fusion. And boom, a star is born. From there, gravity just gathered those stars together to build the giant neighborhoods we call galaxies.
Let's check out Section 4, Life in Zero Gravity.
Okay, so what actually happens to us human beings when we leave Earth, and we don't have this heavy force pushing down on us constantly? I mean, we've evolved from millions of years with Earth pulling on us. Well, without gravity, astronauts physically adapt to space in some pretty wild ways. First off, they totally lose their sense of orientation. Because there's no gravity pulling the fluid down in their inner ears, their brains get super confused about which way is up and which way is down. They also actually grow about an inch taller. Without gravity squishing their spines down all day long, their bodies can finally just stretch out. But there is a catch. Without having to fight gravity just to walk or stand, their bones and muscles weaken really fast. Astronauts have to exercise for hours every single day just to stay strong. Some even say it feels like their arms and legs are just disconnected and floating around them.
And now for our grand finale, Section 5. What if gravity vanished?
So what would happen if Earth's gravity just suddenly disappeared, completely turned off? Now, we know we can't actually turn off gravity, so this is just pure science fiction imagination, but it is such a cool thought experiment. Because the Earth is spinning at hundreds of miles an hour, kind of like a giant merry-go-round, you are spinning right along with it. Without gravity acting as an invisible seatbelt tying you down to the surface, your momentum would just keep going in a straight line. So if you were sitting at your desk when gravity vanished, you would instantly begin to float upward and smack into the ceiling at a wild 33.7 millimeters per second squared.
But honestly, bumping your head on the ceiling would be the absolute least of your worries. It would be total chaos. Instantly, anything not bolted to the ground floats up. Minutes later, without gravity to hold our air down, the entire atmosphere would just float away into space. We'd have no air to breathe, and without that air pressure, the oceans, lakes, and rivers would literally boil into steam and drift away. Eventually, the immense pressure inside the spinning Earth would have nothing holding it together anymore. The very rocks of our planet would just break apart and scatter out into the dark void of space.
So the next time you drop a pencil and watch it fall to the floor, don't just see a dropping pencil. Try to see the invisible space-time trampoline of the universe at work. You're looking at the exact same force that ignites stars, creates ocean tides, and literally keeps our planet from flying apart into pieces. If gravity is the invisible glue holding the entire universe together, what other incredible secrets do you think it might be hiding? Keep asking those big questions, keep doing those fun science experiments, and always remember to look up and wonder at the cosmos.